Well, hello everybody. As you can see, it's the bonus quiz for 5.3. It's actually a three-pointer because I've added some spice. Problem 3 is a review problem drawn from chapter 2 to keep you remembering what you've already learned. This first problem, they ask us to factor out a factor. And that makes perfectly good sense to me. They want us to factor out a factor with a negative coefficient. Now that's, in a sense, a new station. And it becomes a primary skill as we move forward into chapter 5 and especially chapter 6. They want us to factor out a negative number from these three terms. And I'm looking for a negative number that all three terms have in common, and I don't see anything. But there's one that they always have in common. You know that they always have a common factor of 1. Believe it or not, and this is a bit sneaky, they also have a common factor of -1. And so that's what I'm going to pull out from all three terms. I'm going to factor out a -1. And I ask myself, what gets left behind? Remember when we were multiplying by -1 to some parenthesized quantity? I call that minus parentheses, and I wanted you to figure out a slick way to handle it. And it turns out multiplication by -1 is simply a sign changer. Well, it's the same idea when you're going in the opposite direction. Basically, we're not multiplying by -1. We are dividing by -1. And that's a sign changer too. And so all three terms are simply going to toggle their signs. The minus r to the fifth becomes a plus r to the fifth. The plus 2r to the fourth becomes a minus 2r to the fourth. And the minus 4 becomes a plus 4. And lo and behold, I've factored out a -1 from all three terms. What we've done is we've massaged this expression into this form here. And these are two equivalent expressions, so I ought to be able to get back and forth. So if I do this multiplication, I ought to get back my original expression. And you could go ahead and multiply everything by -1, and of course you're going to get back the original expression. What this section is doing, one of the small tasks that it's preparing you for, is, well, something like this, which we're going to see very shortly in chapter, I think it's 5.4 and 5.5, where we're given trinomials like this. Whenever you have a trinomial, and notice this is arranged in descending order, you're going to be asked to crack it, to factor it. And if the first term here has a negative, it is always a very super smart thing to do to factor out a negative number so that the leading term here is positive. And so I'll factor out a -1 from this. I would simply toggle the signs of everything inside here. Now the recipe they give us for factoring a trinomial, this should have been a square, works so much easier on trinomials that begin with a positive coefficient. Let's take a look at the second problem, an expression that has 4 terms, a quadrinomial, if you will. So here is the expression. It is not an equation, and we're going to factor it. Whenever you have 4 terms, always start out by arranging things in descending order. It's a nice way to bookmark a starting position. And so I'm going to write this in descending order. 3, 2, 1, and then x to the 0. And then what you want to do when you have 4 terms is you want to circle the first 2 terms, make a dance couple out of them, and do the same thing for the second 2 terms. This first group, look to take out the biggest bite possible from both of these terms. And I think you can see it's going to be an x squared. I'm going to factor an x squared out from both of these terms. And so that means I got an x here and a -2 here. Notice if I do the multiplication, I get this back. And so it checks. And now what you want to do, and this is a secret ingredient, is you look at this binomial here and you want to duplicate it over here. You want there to be an x minus 2 over here. And so what do you have to factor out to get an x minus 2 over here? If I pull a minus 5 out, it is going to multiply back -5x, and -5 times -2 is a positive 10, so it works. Pulling out a -5 leaves a binomial behind that is exactly identical to this one. And now here is an interesting move. What we have here are 2 terms. Here's the first term, and here is the second term, and there's a connector between them. These 2 terms have this factor in common. And so I'm going to pull out an x minus 2. Pull out an x minus 2. That means I'm going to factor this out from the first term, factor this out from the second term, and ask myself what got left behind. And the answer is x squared minus 5. that is sort of an inside-outside move. It's very tricky, and if students are going to get hung up, that's where they get hung up. Now we get on to the review problem, and this is going to be a graphing problem. You can always replace f of x by y, and I'm going to do that to show you that I have y is equal to some constant, which I called one of those freaky lines. The constant here happens to be -3. And so there's a constraint here that says y has got to be -3, but there's no constraint on x. So y has got to be -3. X can be anything. Y has got to be -3, and x can be anything. And so we might as well choose simple anythings. I'll choose 0 here, and 1 here, and 2 here. So that was the technique for handling lines where you had y is equal to a constant, or where you had x is equal to some constant. You simply generate some ordered pairs with the given constraint. Y had to be -3. It says nothing about x, so x can be anything. And then when you graph these points, what you're going to get is 0 over and -3 down, 1 over and -3 down, 2 over and -3 down. You're going to get a horizontal line. That's the answer. Remember, I had a video where I showed a really quick hack for this. You look at this part right here. This says y has got to be -3, x can be anything. So y has got to be -1, -2, -3, but x can be anything to the left or the right. And there is the line right there. So all that's left to do is to actually use the tools inside MathXL to graph that. And I will put a point there, and it doesn't matter, I'll put it here. And that's it. I'm happy. We submit. Okay, I hope that helps. I'll be talking to you again soon.